Hi, everyone. Thank you so much for joining us today. This is the webinar for how graph and machine learning can maximize customer 360. Today we have Scott and Graham here with us and just wanted to go over a couple of housekeeping items before we get started. First is that this webinar is being recorded and it will be up on our website. Also, you will receive an email shortly after the webinar, either today or tomorrow, with the link to the recording as well as a link to the slide deck. You can submit all of your questions via the chat or the Q&A box during the webinar, and we will have a time for Q&A at the end of this webinar. Thanks so much. Without further ado, Scott.
Thanks, Ashley. Hello, everybody. Thanks for joining us. This is the second in our series of webinars, and I'll be one of your tour guides today, and I work at Expero in our graph practice. We're going to see a lot of good concepts today, as well as get in and see some detail. And with that, Graham, you want to introduce yourself?
Hey, everybody. I'm Graham Gansel. I am the data science practice lead here at Expero. My background is in deep learning and graph.
All right. With that, a quick tour. Expero is a consulting company, and so what we're going to see today are many of the best of breed, as well as best practice in what we see today. And what we specialize in is building products. We also then help our customers to modernize. And then specifically today, obviously, we're going to talk about machine learning. And the other concept we'll talk about today is how does graph fit into this? And we help our customers with UX development, assessments and roadmaps, rapid prototypes. And then ultimately our goal is to train our customers. So enough about us. Let's talk about some of the things that exist out in the market today. We know there's lots of different products, and every day there's more of them, but our job is to be up on the ones that are sort of the leaders, the ones that can actually help you solve your big business problems, and that's ultimately what we spend our time doing. This is not all of the vendors, but these are many of them. Some of our graph customers that we have out there today, our key here is that we do it across industries. And today we're going to talk about Customer 360. We're going to see a little bit of an application in retail, as well as banking and telco, et cetera. But the goal here ultimately is that we help our customers solve problems. Well, we are here today. We are in Customer 360. For those of you who may have seen us previously, we talked a little bit about the last one, which was fraud, and that spans several categories of retail and banking, et cetera. And our upcoming one is going to be supply chain. Many of you, these may be helpful to come to many or all of them, so we highly suggest that you do that. If you have not visited us online at experoinc.com, please do. We have lots of technical papers. Graham has some fantastic, deeper from what we see today in his blog, et cetera. And we have many different categories of graph in detail. Okay. So what we're going to talk about today is what is Customer 360 specifically, and how can we optimize it and save money, as well as many of the topics that are top of mind, such as churn, et cetera. When we look at these kinds of statistics, I think that's ultimately what most of the businesses we work with are trying to do. If you see in the upper left, it can start with simply a customer churn rate. And that is that customers are leaving me and they're going to my competitor. They may be silent complainers. I may not know that they are mad or dissatisfied, and it may stem from a billing or an invoice. It may be something as simple as customer service, or if I go into these days, whether it's a retail bank or I go into a store, all of those things ultimately can propagate into many different categories for the business. And it's whether I'm losing customers, I'm churning customers, I want to retain them, I want to cross-sell and upsell customers, I want to find out more about what's been successful in these categories of items. And in the center, we hear about call centers, which is now people are calling in. We can start to predict when they will call in and how dissatisfied they may be, depending on how our billing cycle may work. And ultimately, again, our goal here is to cut costs, drive revenue, be more personalized, and quite frankly, optimize our business to really function better. And so our goal here now is with these kinds of applications is to create that capability. How do we unlock that ability? Many of us have SQL databases and applications, and whether it's Hadoop or any of the other platforms, and SQL and Oracle and SAP and many of these different things, ultimately, that's what we're trying to solve for. So now, again, these types of things are ultimately part of the 360 conversation. And so whether you are looking to any of these things, in some cases, there may be ones we haven't even talked about, like returns or chargebacks. You're trying to avoid a new business problem by going online when you've had retail stores, et cetera. Those can actually meet themselves out. And that's where we're going to spend our quality time today, is talking about products, these actors, the people, the locations. All of these attributes or traits now become very important in what we can do. So we can become very, very much more proactive in how and what we do when it comes to Customer 360. And that's really kind of setting the table. This shouldn't be a surprise for anybody on the webinar, but our goal here now is, let's get better. You hear about the concept of graph. You hear the concept of we can start to organize these things. We can do structures. We can do things differently. But ultimately, these structures, what do they mean? That's where we're going to spend some quality time. And what we're trying to show here is what we're prefacing here in a few minutes is about graph and machine learning, and ultimately what human beings who have to use our software, what they need to run and do their jobs. They all have to collide, and that's ultimately what we're doing. So my next premise before I hand it off to Graham is that graph is very different, and it's very, very good for Customer 360. In this pictogram, this does a couple of different things. This starts to show what we can do with graph and why it is so incredibly powerful. And ultimately, whether you're looking at the flow diagram at the very top or you're actually looking in the middle, our goal with graph is typically to leave your current systems where they are. And they can be large in number. You can have 10s, 20s, 50s of systems. They can be disparate. They can be custom. They can be SQL. They can be anything, data marts, et cetera. They can be very, very different. Our goal here in this particular diagram now is to realize we can map and start to do some intelligent mapping from those data sources. We're really trying to flatten the data and create, you may hear the term entity resolution. What this really means is if I am a customer record in someone's database, and I'm Scott Heath, I could be in multiple databases. I might be in a shipping database, I might be in a customer database, I might be in a billing database, and my family may also be in those different data structures. And they may be Scott Heath Sr., Scott Heath Jr., and I may have different products and services that I've ordered. And ultimately, what we believe then is through this entity resolution is, first of all, am I the same Scott Heath? So how do I do that? And first of all, I have to then run some, and Graham's going to share with us, potentially some machine learning. So I have to make a match to do that. And then as I do that, I can start to create what we call a three-dimensional view or a graph, which is tell me about all the products that I've ordered in my history. Tell me about all the locations perhaps that I've lived, and perhaps even my social network. I can start to expand on some of these kinds of things as I create now this graph, which is a network or a network diagram, as we will see today. And through that graph, now again, potentially we can serve out that data. We can start to do some very intelligent things over on the right, which is this capability of learning about history. Just because I have bought products and services, my family may buy products and services, and they may do things differently. So not just my customer view, but my entire family, and I can start to look at people that are similar. Potentially, Graham's going to show us then how we can look for whether it's clustering or those kinds of things. I can start to find some trends and do some very intelligent things that many people call predictive. But in that category, now ultimately we're trying to build a user interface. And everybody wave to our customers at the upper right-hand corner. These are the people who actually have to use all of these systems. They have to be in a useful user interface. It has to be usable. It has to be fast. and ever present. And as we're on the web these days, many of the time our customers tell us it has to be scalable and it has to be real time. So this kind of sets the table. Hopefully this is a good pictogram or diagram of where we're going today. Okay. This is a slightly different view now of as we're building that, that data source when we're moving from our SQL or any of our current views. This is giving us now this Rosetta Stone. So as I build each one of these legs in this graph, I'm building a three-dimensional model. And ultimately, I'm looking for the entire history, whether it's for a customer, a bill of material, or in some cases, a combination of all the things that a customer has done, whether it's loyalty, where I purchased them in locations, et cetera, is creating that complete picture. And once I have that three-dimensional graph, I can start to unlock some very powerful things. Now, let's say we did that. We went out, in this case on the left, we went out and found roughly 165,000 customer records. Guess what? We put it in a graph. It's a mess. It looks fabulous, doesn't it? No, it looks like a big yarn ball, and Graham's going to walk us through effectively what we did. But in this case, now as we, in that previous pictogram, as we create that entity resolution, we do some smart machine learning. What we can now do is create this network diagram of things that we can color code, of things that may be in red, that may be something we need to spend our attention on, a customer who might want to churn. And then I can see effectively the other products or services that may have linked to me. And the goal here now is to create, as I mentioned, this concept of a 3D graph in this data model so we can go do some very important things. Most of us know about SQL. A lot of us are learning about graph, and that's okay. But the primary concept as we do that is that in the one-to-many, many-to-many types of relationships, that's what we see in that traditional database. There's nothing wrong with that. There's some very powerful things that we can do. There's some hybrids, whether it's in SQL or Hadoop or whatever those kinds of things are. We can get better and faster with data lakes and those kinds of things. But the real problem then is as we start to do things like recommendation, we want to start doing some analysis. It doesn't really suit our needs, and more importantly, it starts to get expensive. And ultimately now we want to flatten that data model, almost the way we do on a whiteboard when we do a logical ERD or a data map that many of us are familiar with. Because ultimately, when we build that flat model, what you can see here is instead of doing in the background a 15-table outer join, I can actually create a very simple selection of a customer ID out of a graph database that is both simple as well as potentially very fast and efficient in the way we do that. And Graham's going to spend some more time talking to us about why that's so important. But again, the goal here is not to beat up on our friend SQL. It's just to simply indicate that now as we get it into a graph, it's something that we can use. In this example, we're now looking at a retail type of an example, and because we're in a graph model, we can start to identify now a product, and that is a Spider-Man lunchbox. And in this case, it's part of a franchise which may have many other products, and ultimately our goal here is to be an online type of a service provider and recommend in a very fast and real time that, hey, we should potentially suggest an Iron Man toothbrush. Now we can use machine learning to use whether it's a degree or the clustering, the similarity, these kinds of patterns. We can go back and realize that it's not just a recommendation that we'd like to push, or as I call the invisible hand. It's as much, what did history teach us? What have we learned about other products and services that other people have learned, a la Netflix, right? We're all familiar with that model to be able to do that. And again, our goal here in a graph is start to do these things very fast and do some things very quickly based on the items on the right. So now that we have the graph model, these are now the concepts that we want to use. These are extremely powerful. This concept of dependencies, the idea of clustering, being able to identify whether it's friends, relatives, or similarities of other people that may have similar kinds of backgrounds, whether it's products or services for Customer 360. And then this idea of matching. How can we look at dependencies? Because of certain things, other things happened. And then ultimately, we can start to do flow, whether it was from an action to a response, how we've done shipping or fulfilled orders, or some of the other items in that customer chain. And then search. Ultimately, search is tied into this as well. Now that we have that graph, these things become very straightforward and very easy to do, and they don't have to be complex. And again, our goal after we talked about that pictogram was let's leave our data where it is. Let's put it in a format now that gives us this additional horsepower and power to go do those kinds of things. Okay, great, Scott. I believe you. Graph is starting to look good to me. Oh my gosh, again, we're showing this hairball on the left right now. Now that I've done the right thing, I've created that entity relationship, I've created it, but now I've got these very large sort of unwieldy visuals. What we're really aiming for now is something on the right that a human being can start to utilize, where it shows a graph where I need it. I can explore the graph, and as Graham's going to share with us, how do I do this machine learning to create things that matter to either the user in the upper right-hand corner? It may be reliability, it may be risk, those kinds of things. But how do I create a useful user interface and application? Okay, so if graph is good, graph and ML must be great, right, Graham?
That's it. So before we get started with applications and methods, I want to mention to everybody who's watching that you can go to the link at the bottom of this screen to check out Expero's so-called awesome list of graph machine learning intersections. So there's a variety of links, code, articles, and software that you can start using. It's all open and it's there for you. So before we can perform any of the analyses Scott mentioned, we have to ensure that the records we're looking at are the right ones. So we're going to do that by performing this so-called entity resolution step. So we start with databases on the left-hand side of this slide. They could be in any form. Scott mentioned a few, SAP and Oracle and SQL and whatever. Doesn't matter to us. We're going to build this ETL pointer map back to the source data databases. And then we're going to use this machine learning system, which I'll touch on in 2 slides, to build an intelligent same as graph. And what we have here is a canonicalized or deduplicated record of all of the customers that your organization has interacted with. Once we have the same as graph information, we can begin to build out back-end interfaces, APIs, and indeed end user applications or in-house applications for use in figuring out where the value is. What are your customers doing? Insight into where they exist in the customer journey. These are things we'll touch on in the next few slides. So the piece of tech that exists behind this black box machine learning entity resolution system on the previous slide is just this. It's a pretty simple system. It is a text comparison algorithm which learns the record weights that are optimal for building out customers and the relationships of products, services, and company interactions to that customer. In number 3 on this slide, we see a clustering algorithm, which groups all these things together. And that's how we insert this whole customer view into our same as graph. So maybe you don't care too much about supervised and unsupervised learning methodologies, but I will say that both are important in building the whole picture, which is this piece. All you need to know is that you start with a messy multiple data storage system, and you end up with not only beautiful, usable customer insights, but you also end up with risk metrics or customer graphics, which represent variety of metrics that you can discern about your customers in an automated way. So these things, the machine learning system will analyze your customers and it will highlight these things for you. So either your analysts can make further decisions, or investigators could go potentially figure out what's happening with your customers and attribute causes and recommend intervention strategies, which is what we'll talk about next. So this section is about customer metrics, and you've all seen a churn model before, so anybody can build a churn model. But I will say that using graph, we can not only use the properties of your customers, we can also use the connections between customers, similar customers, disparate customers, and groups thereof to build more powerful analysis. By doing that, we can actually prescribe why these customers have churned or are likely to churn. And then we can recommend intervention measures based on your specifics. So we see a customer with an 80% churn risk being fed into this complicated machine learning system, which is sort of unimportant. But what it does is recommends actions with likelihoods, including a consideration of price in intervention tactics. So on the left-hand side, we see some prices for hypothetical intervention tactics. And on the right-hand side, we see a predicted risk outcome. So this says, if you call this customer, if your customer representative interacts with this person live on the phone, you reduce that risk from 80% to 62% of churn risk. So you've done 18% better in this case with a phone call. Obviously, if you send this customer, and the last option is gift card, if you send them a $25 gift card, you're going to do a lot better job. But again, it costs you 25 bucks, whereas a phone call could be much cheaper than that. So we perform this analysis. This is automated again. This machine learning system in the middle does it. And then we insert this information back into our graph, the representation of your customers and their relationships to the products and services that your company offers. We have extracted this is from real data. We've extracted a customer subgraph here that is actually a collection or conglomerate of related customers that are grouped in some way as a cohort, right? So maybe this is time, something simple like time, or maybe it's something more complicated like their taste in product X. And by doing that, again, we can iteratively increase the power of this analysis. So the next section is about treasure hunting. This section is it's a broad topic, but it's a thing we find our customers really like to use. So this is sort of a finish to order idea here that Expero likes to offer to a variety of customers. And it's best explained through the sort of historical analogy here. So I'm sure that your business analysts, your data analysts can pick out trends which lie outside of the norm. But increasingly, we're not interested in those cases, that those problems are solved. So nowadays we use graph plus machine learning to discover higher level insights in your customer database and in their preferences. So on the right-hand side, I have a representation of a graph, which is that purple and gold diagram. That's called an adjacency matrix. And the other image there with the dots on the scatter plot is an embedding of that information, where we are able to actually discern this new customer cohort, which was impossible to tease out using traditional methods that are employed across the industry today. The next topic here in the treasure hunting section is about, again, prescription. So, okay, sure, we can find these customer cohorts, or we can find these interesting relationships between company services or their satisfaction constraints to customer cohorts. But how do we make sense of that information, and how do we act? How do we make business decisions based on those? You don't want just a percentage score. In the end, what you want is an actionable insight, right? So we have on the left-hand side, we have an extraction. Again, this is a subgraph of a customer with their relationships to products or services. And on the right-hand side, we've actually represented the customer base or this customer cohort in a way that explains or describes in terms of a clustered relationship setting why these customers are related, right? So then we go back using this information and we can correlate effect back to causes. So in these two different cohorts we're showing on the right-hand side, we find two different causes of dissatisfaction. And that's important because you can go back and you can perform, again, intervention measures, or you can change how those customers interact with the business. And this is one of the ways you can do that. So we have a couple of different cartoon slides here about how to make recommendations to customers. Now, these so-called recommender systems are very, very powerful algorithms. Scott mentioned Netflix earlier. So the algorithms that are used by these top tier technology companies are the same types of algorithms we're employing, so-called collaborative filtering, matrix factorization, these hot words you hear in the data science space. But the reason that we wanted to mention them in this talk is because you can actually do a better job than using relational data. By using graph, you extract more relevant information about your customers. So here we see a couple of customers who've purchased similar items. So we build a similar edge between customers. And then this algorithm says, well, customer 2 also bought this item. So perhaps customer 1 would also be interested in that item. So that would be a product recommendation based on graph machine learning. So here's a more technical representation of a related process. So we have a customer on the left. Again, these are the products that we know he's interested in buying. And we use the so-called graph autoencoder on the right-hand side of this diagram to figure out which of, based on similarities between products, which products would best be cross-sold or upsold to this customer. And again, if we think about the customer cohort graphs I showed earlier, not only can we do this for a particular customer, but we can also leverage the information about the related customers and related customer groups to make very intelligent recommendations that you can't do simply using relational data. And that brings us to how satisfied the customers are. So we have a variety of processes we apply to discern, predict, and prescribe customer satisfaction. So I've represented just a snippet of some things we've worked on here. On the left-hand side, we have a standard sentiment analysis. This is a deep learning technique where we try to figure out what the customer's interaction was like with the company. So we can apply this methodology to text. So maybe you have online chat with your customer representatives. Of course, you have phone calls with your customers, and hopefully those are recorded in some instances. Even videos, so any interaction you have with your customer, we can perform sentiment analysis to tease out the customer's mood with respect to those interactions. And when we do that, we can actually start to build up a satisfaction model because, again, we've already built this graph that relates all of the information about your company to this customer, and again, to cohorts of similar cohorts of customers. So we can start to build up ideas about why these customers are satisfied or dissatisfied and prescribe individual actions to intervene. So we have two customers here in this customer cohort who are labeled as silent complainers, right? So these are people who obviously have been dissatisfied by some interaction with the company and are not doing anything like contacting customer service to attempt to make amends. But they are at a high risk of churn, and you want to address this problem. So using this customer satisfaction deep learning graph methodology, we can tease out the silent complainer details, the customers from their cohorts. Additionally, and this is maybe the biggest insight of all, is where are your customers in the customer journey? So here's a fake name for one of our customers who's a big box store. And we're using this graph. This is an extraction of a customer database. The edges in this graph are the purchases in common between customers. We take this information, we build up a so-called feature vector, and we input that information into our deep learning system. What comes out the other end is metrics or suggestions about what these customers are doing. Where do they exist in the customer journey? How are they likely to next interact with your company, right? So again, starting from the left side, moving to the right, we know things about the customers, their purchases, their interactions with your company, and we can derive information like this is a business traveler. Right? And because of that, we can make smarter suggestions to your employees about what to offer next, right? For instance, a business traveler, maybe she needs toothpaste on her business trip. So automatically send a coupon to her phone, thus driving up customer satisfaction, decreasing those negative metrics like churn. Back to you, Scott.
Well, hopefully you followed that graph was great. ML was even better, but now how do we get the final leg in the process? We've got to get our users aligned. And if we can do those three things, we believe this changes the game incredibly. So as Graham mentioned, what do those user interfaces look like? This ability to create a dashboard, whether it's for management, analysts, or executives, is this activity of doing the real intervention, is stop it. In this case, we're recommending potentially to retain a customer, but we're creating proactive activities because the business case on this is one customer, we spend hundreds of dollars to acquire them and now thousands of dollars to reacquire them. In addition to we lose their money, can be hundreds of millions of dollars in a business case. Again, this ability to do something as simple as flagging people, whether their activity is low, using the graph to create the things that Graham discussed previously. It's these simple things that a human being has to be able to digest, and more importantly, visualize to create that answer potentially for the business. And although that seems very straightforward, we've seen today that there is a level of this that we need to do to stop what we were talking about. A couple of concepts for those of you who have not seen these before is this ability to do these kinds of things, and these are some of the terms with a visual to go with it. In this case, we want to look at that entity. In this case, it potentially is a consumer, a buyer, and we can start to traverse that graph, whether it's an individual customer, it starts to get into the graph of those edges, or as we call them, other people or attributes in that. And then again, it's in a nice user interface where I can go see things that we typically see, master and detail information, etc. We can start to see things geospatially. In some cases, as graph starts to become more interesting, if you see things in context of a map, you may get different insights. It may not just be about people, it may be about where they're doing things, and in some cases, the timing of those. We can also see this as an overlay. We live in a very mixed world. In this case, we've got some nice OLAP and some standard SQL kinds of reports, maybe a Tableau, a Cognos, or those kinds of things. So again, the dashboard and what we're showing in the visualization doesn't have to be just from one source. Now we talk about a timeline. In this case, we're seeing a sequence of events, whether it's, in this case, these are violations, but this could be activity from a customer. Let's say each time they come in and report something, or they call back, and as Graham mentioned, their satisfaction starts to get less and less, and therefore the score goes up, which means we probably need to do something sooner rather than later, and that score can be used for other kinds of actionable intelligence. The other kinds of things then is we can overlay that information as we're looking, again, in this case, a combination of things. I can see my SQL information across the bottom, but the scoring makes me aware of certain categories of things and things that I need to spend my time on, which quite frankly, we spend a lot of customer activity with, which is what do I spend my quality time on, and what, quite frankly, do I not spend my time on? And then finally, we can show this information, again, whether it's with this OLAP or mixed environment, we can have visualizations that are fairly traditional, and most of us are familiar with the BI and those kinds of tools. Okay, so now let's go look at an application. And I think Graham set the table. We talked a little bit about what Graph does for us and the things that we can do. And now we've got an application in front of us. And this is, again, for our Nile Trading Company. This is a global company that sells goods and services all over the world. But in this case, I want to look now in a specific region. So now I'm treasure mapping at some level. The business case that we want to try and identify here is potentially a customer that may churn from us, as Graham mentioned. Again, acquiring that customer, we spent a great deal of money. Losing them both means losing them and then potentially having to reacquire them. And in the new world, social impact. So if you don't just lose one customer, you could potentially lose multiple customers because they're socially influential. In addition to now another use case in the same dashboard would be cross-selling to current customers that actually do enjoy our products and services. And again, very quickly, I identified maybe a couple $100 million in return on investment. Very, very important business aspects of what we're trying to do here. In this case now, I'm going to go click on this region, and I'm going to do something that we refer to as segmentation. Now we've used the graph data, and we're starting to look at things and slice and dice. In this case, I'm looking for, as Graham mentioned, these buyer behaviors. I'm starting to segment these based on age. I may actually start to change those depending on social influence. These days, who doesn't know about social influence? If you like a product, the first thing we do is we go out online. Through some open APIs, we can actually now start to identify whether this person potentially is known to us. So they may have loyalty card, they may have customer points, those kinds of things. And again, I can go look at their social network and realize, well, in this case, I have a customer that is extremely influential, and I actually want to potentially bring them back because they've been buying from me, and I want to create a targeted segment activity. In this case, I'm now going to create that customer retention. I do not want this customer to get away. I've noticed that they're extremely socially active, so not only am I just going to give them a coupon, but I'm actually going to give them and their friends a coupon. So instead of sending $5 million of $1 coupons out to my entire blanket market, I'm actually now subsectoring perhaps a $5 coupon to a very select group of people who potentially now are also socially conscious. So I'm able to now tailor that message specifically to this target demographic. And now this is what our user sees. So simply that, gosh, I'm committed to the environment, and it looks like this company cares about what I care about. So not only can I either use my loyalty points, or I'm going to make a difference, but now I can share this with my friends. And the goal here now is to create something that's both important and impactful for what we're doing as we do that. Okay, a couple of different other things we can do now. In this case, we want to go back and look now. How did we see those trends? So now I can look at my dashboard and realize that I have a certain region, and I have multiple categories of things. I've also got another campaign over here where I can now see that in this case, I've got customers that actually like our products and services very much. I have a different category where, as Graham mentioned, I can actually go look at products and services and recommend now to that person. What's happened here in the upper one is we'd like to recommend these. Now the one at the bottom is something I refer to as the invisible hand, which is maybe in that region we have quite a bit on hand, and we're actually running some sales, and we actually want to move some inventory. So we can do both of those things in this type of analogy. Okay. The other thing that we can start to do then as we walk through this is how I set it up, is that I can come back now. Now I actually want to go do what we call this look back, in some cases, segmentation of a customer. So now we use our standard search, and I can go do these filtrations. We're all familiar with these kinds of things, but now I can use things for loyalty, how active have they been, those kinds of things to go do that. And now I can start to segment. So when Graham talked about relevance, sentiment, purchase activity, I can start to do this sort of leaf level up to the branch in the tree, is what are their affinities, what are their purchase patterns, what are the things in similarity that we can do. And again, we're seeing how the machine learning has touched here in all of these screens, whether it's the individual at risk, it's this sorting and segmentation, things that we take for granted are happening on the backside. And now again, when I open this individual here, Fran, I can see that his purchase activity has gone way down and that his sentiment is there. And again, I can reach this by looking at the bottom up. So I could go look at these types of people, or you could do what I did, which was the top down in either way. The other item that we can do now is, let's say we've done everything we suggested we want to do for the business. People are going to come to our stores. They're going to go buy those things that we're recommending, and there we go. Now we have a tie-in for how graph potentially can be in our supply chain, which is, let's say the lines in red are a shipment of our koozies that are going to be in our store in that region, and guess what? There's a port strike or some other kind of weather delay, whatever it might be. I actually want to now go find out, have I oversold, or can I actually deliver that product or service to that different area? And of course, this is a tie-in for our supply chain webinar coming soon. So what I've now shown you here is in a few clicks, the power of what we're talking about, the way that then the graph worked for us. We were able to use that with machine learning and now tie it together with the visualization. Our goal here is to create something powerful, something useful, and something more importantly that can drive the business. Okay. Now what, Scott and Graham? This has been fantastic, but where do we go from here? That's a good question. Typically what happens is our customers start to realize that whether it's a discovery, it's building a pilot, and then ultimately a full application, you got to start somewhere. And ultimately what we suggest here is that we start to work with our customers, and you can do this whether we help you or not, certainly we can help you, is this concept of what a rapid prototype is. Typically what happens is you take the data, and the reason why this is slightly different than some of our SQL applications is the data typically drives so very many things, as Graham pointed out, is without that data, we can't do too much without it. And then ultimately, that's how we can now drive in on that data, determine the more effective presentation, and then build a working prototype. And then if we need to, we can iterate. But again, the goal here is very large data, and the concept now of where we're going can be overwhelming. Some of the older user interfaces that we used to use may not work so well as with a graph. They sometimes fall down. So again, this prototype with real data is extremely important as we start to engage early and often with our users. So again, quick punch list for you at home, whether you do that or we help you do that, that's typically what happens in this stage. Okay, with that, looks like we're a couple minutes right on time. That wraps up our webinar for today. We hope this has been enjoyable for you. If you're interested in supply chain, we'll have a similar type of a talk on the 28th. And again, our goal is to share both of these with you. And with that, we'll hand it back to Ashley.
Awesome. Thank you guys so much. That was incredibly useful and informative. Just a reminder, you can submit your questions via the Q&A box down below or in the chat, and we will begin to answer those. And to start off, I have one here for you, Scott. How much data do I need for a proof of concept?
Great question. When we look at the size of the data, it's as well real data versus falsified data. So typically, we're looking for thousands of rows, doesn't have to be overwhelming, but a large amount of data. And then Graham, how much data would you need to start doing some machine learning?
To do a good job on predictive analytics tasks, you want enough data to span the entire use case that you're working with. So that's sort of an opaque answer, but I would suggest that if you have thousands of samples, that you're in the right ballpark. You don't need necessarily hundreds of thousands of samples, but you do want the data to cover all the use cases that you want to start to learn about.
Awesome. I have another one here that says, is Graph a product you built, or are you referring to a generic graph database?
Great question. Expero doesn't build graph databases. The great news is that there are many wonderful vendors that provide that to you today. And our goal is to not rebuild the wheel as we see it. Many of the products that exist today all have different capabilities and can do things. And so we do not build one. And so what we've been talking about today is what we would consider to be a vendor of your choice. And that could also be open source.
Okay, Graham, I think this one's for you. Can I use Graph and ML without each other?
Yeah, of course. I certainly don't advocate imposing a solution before you know what the problem is. We find typically that the combination of graph and machine learning is very, very powerful, but it isn't applicable in every case. And where each piece is not applicable, we don't want to force those things together.
The other good news is that the law of coding physics still applies, which means that good old coding, good old elbow grease will still have to occur. As we talked about that first pictogram that kicked us off today, there's lots of code and certainly work that has to happen in the middle, and that's our goal, is to be able to share those experiences with you.
Okay, another one here is, does Expiro have any experience in the automotive industry?
Yes, we do actually. We've done some of the larger automotive, and that actually is a great segue for our webinar next time, which will be for supply chain. So both route optimization, the act of manufacturing, optimization inside of products, bills of material, et cetera, all the way out to source. So good question, and the answer is absolutely.
If you're interested in learning a bit more about what we've done, or if you have a specific idea that you'd like to brainstorm with us, contact information's up on the screen.
Yeah, and I think that's the good news is we've been doing this for quite a while, so we have a lot of interesting case studies that we can share with you one-on-one, or if you liked what you heard today and you have others that might want to do another version of this, but more specific with your use cases, we're happy to do those kinds of things as well. Believe it or not, that's what we do for a living.
Typically, how long does a POC take to complete? And for those of you who didn't catch it, POC stands for proof of concept. So how long does that typically take?
So your mileage may vary, which is a depends answer, but typically 4 to 6 weeks is what we budget. We try and keep the use case specific. We try and keep the data real, and we try and build a user interface to be able to get direct contact from the users of the system to be able to do those kinds of things. But our goal is to time box it and make it impactful to the business as opposed to stretch it out.
Awesome. I also see a question regarding coming on site. And the answer is it depends. So if there is something that you wanted to, for your team to be trained on, or if you want to do a discovery session, it's absolutely possible for us to come on site, and we would just need more detail about what issues you're having and how we can solve them.
Okay, thank you, everybody. If there's no more questions, we look forward to seeing you in the supply chain or hearing from you one-on-one. Thanks, Ashley.
Awesome. Thanks so much. This will be posted later. Hope you guys have a great day.